Today's problem is smaller or equal elements. This is part of the 12-week interview preparation kit on InterviewBit. So pause the video, go over there, try the problem, and then come back. We'll walk through it. Difficulty, this is rated as very easy. Here's the problem description. Given a sorted array, or actually in the Java template here, it's a list of size n. Find the number of elements that are less than or equal to b. So the input is a list of integers, that's a, and an integer b. Our job is find the number of elements in a that are less than or equal to b. Note, expected time complexity O log n. Okay? So really it should occur to you, even without that hint, that a binary search is the best way to do this. You can, you could do a linear search, but the fact that the array is sorted, is a hint that you don't want to do a linear search. That what you want to do is a binary search. Problem constraint n is between 1 and 1,000,000. What is that's the size of a. Okay, and the elements in a, as well as the integer b, are between 1 and 1,000,000,000. Input format: a is the list of integers, b is the integer that we are trying to find elements less than or equal to, right? Yes. Okay. All right. Well, let's look at pen. Let's look at this for a second, and then we'll look at the algorithm. 1,000,000 elements. Okay. So 1,000,000 elements. If you do a linear search, that's adequate. That should be adequate. I usually ballpark these at 1,000,000 operations per second. Should be fine. But compare it to a binary search. Okay, so binary search, we're going to cut the search space in half every time. How many comparisons do you need for 1,000,000 elements? Well, it's 2 to some power is 1,000,000. So 2 to the 10th is about 1,000. So then 2 to the 20th would be about 10,000, 30th, 100,000, 40. So instead of 1,000,000 comparisons, we're down to, worst case, about 40. It's a big difference. All right, let's look at the algorithm. Binary search. So we have two. And actually, let's get an example here that we can work with. Low, low, and high. All right, so we're going to set low right here to 0. We're going to set high to size of a -1, which in this case is 4. Count. Count, we're going to initialize to 0. We're going to count how many elements are less than or equal to b. All right. So while low is less than or equal to high, mid will equal low plus high divided by 2. So that's 0 plus 4. 0 plus 4, 4 divided by 2, it's 2. All right, so 0, 1, 2. So mid is right here, mid. If the middle element is less than or equal to b, that's line 10 here, then all the elements to the left of mid are also less than or equal to b because a is sorted, so we can count them and then continue searching to the left, to the right of m for more numbers. So how many numbers how many numbers would we have if mid is 2? Well, we've got 1, 2, 3. So the count is going to be mid plus 1. Low, we're going to adjust low to mid plus 1. So low is now 3. So low is right here. And let's erase it from here. All right, we'll go back up. Low is still less than or equal to high. Mid is going to be low plus high divided by 2. 3 plus 4 is 7. Divided by 2 is 3. All right, so mid is going to be here. Is mid, array at mid, less than or equal to b? 4. And b is 4. So yes, it is. So now count is mid plus 1. I'm sorry, I forgot to update that last time. Count went to 3. So count is now going to go to 4. We found 4 elements that are less than or equal to b. And low is mid plus 1. So actually low is now going to go here. We'll take it off. Oh, it's not the one we want. We're going to take it off here. All right, going back down. Is low less than or equal to high? Yes, actually it is. It's equal to high. So mid equals low plus high divided by 2. 4 plus 4 divided by 2 is 4. And so mid becomes 4. Everything is 4. Okay, get rid of that. And mid is 4. Okay. Now, is the array at mid less than or equal to b? Well, it's 6. So no, it's not less than or equal to b. So what happens then is high goes to mid minus 1. All right? High is gone from here. It goes here. Now we go through the loop again. Is low less than or equal to high? No, it is no longer less than or equal to high. We drop out and we return count, which is 4. Right? Where's the answers here? Example, output 1 is 4. Okay. Let me add one more thing here. And that is, we're initializing count to 0. And then here on line 11, this is the only time that we use count, is we set count to mid plus 1. Now at the same time we set count to mid plus 1, we also set low to mid plus 1. So count and low are always going to be the same, which is telling me that we don't really need count. That we could just return, we could do without count and just return low, right? So let's try this. Let's get rid of, I'm scared. Oh, I thought that was going to comment it out. Hold on. Oh yeah, okay. Comment that out. Comment out count. Go down here, comment out count, and we'll return low. All right. Get rid of all of this, and let's go ahead and try it. Yay. For the day, let's see, get ahead in your interview questions from the next day. Okay. All right, we're done with week 1. All right, thanks for watching. If you found this helpful, please hit like, subscribe, check out the playlist on your screen. You can keep improving your interview skills. Also, check the video description and the pinned comment. They both have links to more resources. including a free LeetCode patterns cheat sheet. One of the patterns is binary search. You can download that immediately. It's free. There's also a link to Code and Conquer, which is my complete coding interview prep course. That's it, and we'll see you next time.